Another important configuration is the sampling rate configuration. So last time we used 48 kilohertz, but we can also change to multiples of 48 kilohertz, 24, 12, and also we can adjust to 44.1 kilohertz. So for that we need to take a look at this USB stick technical reference, and we see that there is an external oscillator of 12 megahertz that is connected to this pin called M clock. So the sampling rate will be calculated by taking this reference of 12 megahertz, and then there are a lot of registers that we can set, and we can divide and manipulate these 12 megahertz to achieve the desired sampling frequency. So for that, we've seen that it exists here an internal PLL. So PLL is a phased locked loop. So it's a control system that can generate an accurate output signal of frequency equal to or a multiple of the input signal frequency. So in this case, we have this external 12 megahertz that's going to be used as a reference, and we can manipulate that to achieve a desired sampling frequency. So the audio codec provides the option of using the on-chip PLL, which supports a wide range of fractional multiplication values to generate the required clocks. So here we have a block diagram of the PLL, the dividers to achieve different clocks. So we can select different references. In our case, we are going to select the M clock. Then the codec clock we can also select different values and different signal reference, but we are going to select the PLL clock. So the master clock will be used, and then we will have this manipulation here. So we have registers R, J, D, and P, and then from this clock we will achieve the PLL clock that will be used for the codec clock in, and then we can also change these values here to achieve the final sampling frequencies. Yeah? So there are several programmable clock dividers to help to achieve a variety of sampling rates for ADC and DAC, and clocks for processing block. So as I said before, the clocks for the ADC and DA require a source reference clock, and we are going to use the M clock that is connected to this 12 megahertz external oscillator. So the source reference clock for the codec can be chosen by programming the codec clock in value on page 0, register 4. So this we will be selecting which clock we are using, which reference signal we are using. And also the PLL can be programmed in the page 0 registers 5 to 8. So the register 5 we can turn on and off the PLL. Then we on digit 7, and we can change the values of the P register, the R register, the J, and the D, and we have some formulas to calculate how to achieve the final sampling rate. For that, I just created some functions here to help us to understand. So for example, if we have here this is the formula to calculate what is the PLL clock from here. So if we have the M clock here, and then there is this block, we set values for on these registers, and then we will have this PLL clock. So for example, if we have our 12 megahertz, and then we set R equals to 1, P equals to 1, J equals to 7, and D equals to 1680, then our PLL clock will be this value here. Now we also have different clock dividers to get the value for the codec clock in and the final frequency here. So the codec clock in we'll have this PLL clock, and then we have these extra dividers to achieve the sampling frequency. Here I'm providing this some functions just to make things easier to calculate the desired sampling frequency and to understand what's going on in these blocks to get different clocks. So this, we will calculate the PLL clock according to the PLL clock in. So if we select the M clock, in our case, for example, is 12 megahertz, and we set R, P, J, and D to these values here, 117, 1608, we will have this value for the PLL clock that's going to be here. Then the codec clock in will use the PLL clock. So, and then we have this extra clock dividers, and then we have our final sampling frequency. So here we have also the registers for the codec clock in clock dividers, and here I also provided a formula, so you can get these formulas from the data sheet. And then if you have the clock in is the PLL clock, and then we set values, for example 72, 128, and this is the clock in is the PLL clock, and then we have 48 kilohertz. So to make things easier, we are going to try to keep things constant. We are not going to change the reference clocks, and we will try to, for example, leave D, J, and R and all these clock dividers constant. We will change just the value of P, and then we will have some different sampling frequencies. So with this function here, I can, for example, if I want to have the sampling frequency of 12,000 hertz, I need to set the PLL PR register, this is register number 5, to this value of C1, and then I have 12 kilohertz. If I want the 24 kilohertz, I need to set to this A1. So this is what we are going to do on the next step.